Hi, so today we will solve these three problems from the 1D DP, one dimensional DP. So after that, we can start with the two dimensional DP. So yesterday, I have uploaded the video of this particular problem, longest increasing subsequence. So let's start with the first problem, which is maximum product subarray. So the problem says given an integer array nums, find a subarray that has the largest product and return the product. Okay. So we have to find the largest subarray with the uh, we need to find the subarray with the largest product. Okay. And we need to return that product. Okay. Okay. So the product will fit in integer. We don't need any long value. It will be fitting this range, this integers range. So for this particular example, our answer is 6. Okay, so this particular product 2 and 3 is the maximum product, I think. So that's why we are returning 6 here. Is the largest product 6. Okay. Then we have this particular array. So here the maximum product is 0. Either we take this full array, that will be 0. Either we take this 0. If we take only this array, then minus 2 will be smaller than 0. So okay. So I think it's similar to Kadane algorithm. So in Kadane algorithm, what we do is we use this algorithm to find the maximum sum subarray. So I think for reference, you can solve this particular problem: maximum sum subarray, maximum sum subarray. Hmm. Okay, so this particular problem. So here, what we need to do is we need to return a subarray with the largest sum. So means here the answer is 6. So the array which has the maximum sum is this particular array having the sum 6. So we will use a similar approach which is used in this particular question. I think we have solved this question in this series. Okay, so we have solved this question in this particular series. No, we haven't solved. We can solve, no issues. Okay. Okay, so what we can, so how this problem is different. So here, what we can have is, suppose we have, let's first take the first edge case where all values are negative. So if all values are negative, so let's say this is the subarray having all values are negative. So in this case, the maximum product, will it be -1 or will it be 24? So the maximum product here will be uh, the product of the whole array, because minus multiplication of minus and negative value cancels out. So here it will be 24. But what if we require, suppose if we were solving this problem where we require the sum, largest sum of the subarray. So what we need to do here is we need to pick this value -1. So maximum sum here will be -1. So this is how these two problems are different. So suppose if we had some 4 value here and -5 value here and a 2 value here. If we need to find the maximum sum, then maximum sum will be 4. But if we need to find the product, then product will still be the product of the whole array. Means here the even number of negative values we have. So we need to modify our Catanese algorithm. So what we can do is, suppose we start from here. Initially our product is minus 3. This is the maximum product we have. Then we go to this position and we check if the previous product we have into this value is maximum, or this current value is maximum. So now we have this value as the maximum, means 4 as the maximum. Okay, so also we need to store this value, means minus 12, for future, because what if we encounter another negative value, means if we encounter minus 5, we need minus 12 to calculate that sum, that product. Means we need minus 12 into minus 5 will be uh, into 560. So till here we have the maximum product as 60, and then we reach here, then 120. So we need to keep track of the minimum value also, along with the maximum value, so that we can use that value in the future. Okay, so what we can do is, let's first find the length. So the length will be nums dot length, and let's say our we need a value, means current maximum product. We need answer. So let's initialize answer as the zeroth value. We need the maximum value, means the current maximum value we are having. So it will be initially this value itself. So let's say if the length of the array is 0. Okay, so array's length will be always greater than 1, so we can access zeroth value. And we need a variable minimum variable. So minimum value till now, we need to keep track of the minimum value also. So it will be also nums of 0. So now we need to uh, start our iteration. Let me consider this example. Minus 3, 4, 5, minus 4, and 2. Okay. So initially we have minus 3 in all our values. So now we will start from this value, 4. Okay. Let's assume at the end we will be returning answer. So standing at this position, we will have two options. Means what we can do is, we can take the, we have minimum value till now. Okay. Maximum value till now. Okay, and the nums of 0. Okay, means the answer. Okay. Okay, in the case of negative value, we need to consider the uh, okay, we have positive here, so we can simply what can we do here is, we can simply make our answer as the maximum of the current answer and this particular value. So okay, so max here is minus 3, so we need to update the max. Okay, so max will be like max dot maximum of the current max value and the nums of I. So now our max will be 4. Okay, max will be 4 and our answer will be maximum of the max value and the answer itself. Okay, and we also need the minimum till here. So let's say our minimum till here will be max dot minimum of current minimum we have and a minimum into this value. Okay, suppose we have minus 3, then we have 4. So in this case, minimum will be minimum into nums of I. Okay, okay. So what we are doing is we are having minus 3, 4, 5, minus 4 to both are minus 3 till here. So then we encounter 4 means our value is greater. So we can have four values of four, then this situation. Mm, So minus 3 starting from 4, then max becomes 4. Okay, max becomes 4 and answer becomes 4. Four, 5, minus 3, 8, 9. Mm, Means if this is our negative minimum sum. Mm, what we're doing, maximum sums of array. Maximum sums of array. This is the array. One stroke length, answer 0. Current max will be here on answer 0. And we start from this first element. What we do, we check means we add the current element, means we have this array, means what we do, we will add this number, let's say this example, 4 minus 3 and 4. We take this number and then we consider this number. Okay, we have considered this number, so this will now give us 1. Basically this will be 1, and we make our answer as the means if this particular sum becomes smaller than 0, then we don't need to consider this particular subarray. Then we can move on to the next subarray, means if it becomes negative, means if adding current number becomes negative. Another example for this is if we have 1, 3 and minus 4 and 5, so minus 5, sorry, so if we have added these numbers, but if we are adding this number, so this number is causing our sum to be current sum to be smaller than means negative, so no point of adding this particular subarray. Then we can move to this subarray. So we take our current max value as the maximum of the current max value we are having, and current max value if we are adding the current number to it. Okay, so for here we will have 4 as the current max value, and what we will do, we will take maximum of this current max value and this answer. Initially we have 1 as answer and current max, we take 3, so the current max becomes 4, our answer becomes 4. If we reach this condition minus 5, so what here becomes is this becomes negative, so our current maximum still remains 4. Okay, so we don't need 4 here, we can take it as the 0. Okay, or for this particular case, initially it's 4 and adding minus 3 will not make it negative, so current max will be 1 and answer will still remains 4. Okay, when we reach here, then our answer becomes correct. So this is, I think, Kadane for maximum subarray sum. We need to implement similar approach for this particular problem, maximum product subarray. But here what we need to do is, if we encounter, if this is minus 3, so till here we have 20 as the maximum sum, then this sum becomes negative, multiplication becomes negative. But we need to store this multiplication, means we need to store this multiplication because we can encounter a negative value in future, so that the negative multiplication to a negative becomes positive again. So that's why we need to store this minimum value till now. Okay, minimum value till now. So how we can store that minimum value? Let's rename it as negative or data answer every time. If negative is found, we update the most negative. If positive is found, we update the most positive. Okay, means if over this we have found this value, means if the number is negative, if the uh, nums of I is a negative number, that means we need to update our minimum value. Hmm, no, we have a negative value here, so let's say we are going, we have 4, then we have 5. Okay, two positive values, we get their multiplication, means we get their multiplication. Okay, negative value is found, we update the most negative, we update the most positive. Then we encounter a negative value. If we encounter a negative value, in that case our maximum can be the current maximum we are having, or the multiplication of that minimum value into current value. means if it's negative, then our max can be, if suppose this is negative, then our max can be multiplication of the minimum value and the current value. Okay, max of the current max and the minimum value into the current value. Okay, mat dot minimum of min value into temp into current value. This is 4, this is 5. Okay, initially we are at 5, so temporary value will be 4 itself, and maximum becomes now this value, and minimum, but minimum still remains 4 here. Okay, till now the maximum what we have reached, but that will be, this will be this itself. Okay, so we have 4 into 5, 5, 16. So min will be minimum of, okay, let's say for now it's 4, but what we've reached here, okay, minus 3. So temporary value will be 20, maximum will still remains 20. Okay, and minimum becomes minimum of 4, and max means 20 into minus 3, which is minus 60. So minimum becomes minus 60 and answer becomes 20. Okay, then we reach here at this value. Now our maximum is this value, 5 and 4. Okay, 5 and 4. Okay, so then 5 and 4 is the maximum 20. Then we have minus 3. So minus 3 here will give us minus 3 and 8. Okay, so it will cause an issue that 20 into 8 will, this will give us some greater answer. Okay. Means if we encounter a negative value for this particular case, we have stored our minimum but not the maximum value. Okay, minus 4, 20, we go to minus 3, then 8, then 9. Okay. So here we have 20 as the sum, 20 as the product. Then once we reach here, we need to reset it to the 8 again. Suppose we have 40 here, then in that case we need to reset once we reach here instead of considering this. That's why we have minus 5. Max of 10 and 1 so 5. Okay, and we take minimum as minimum and temp into, so we'll do it temp. Let's run for this example. We will have 4 inch, temp will be 20, max will be 20, minimum will be 4, answer will be 20, then we reach minus 3. So maximum into minus 3 will be minus 60. So now max becomes minus 3. Okay. Minimum becomes minus 60. Okay. Answer becomes 20. Then we reach here 40. So temp becomes this product max becomes 40 and minimum becomes this product. Okay, and answer becomes 40. Then temp becomes max value, so temp becomes this value. Now the maximum is becoming maximum of temp and nums of I. Okay, means maximum of this multiplication or this alone, but here it needs to be multiplication of that minimum value with the temp value. Okay. Okay, wait, we will first move to the next problem, then we will again think of this. So we just missing something here. So let's move to this problem word break. Okay. So the problem says given a string S and a dictionary of strings, word dictionary, return true if S can be segmented into space separated sequence of one or more dictionary words. Note that this same dictionary may be reused multiple times in the segmentation. Okay. So we have this dictionary having words. Then we have this. What is this? This string. Okay. We need to see if we can split this word. I think so that all the words are present in the dictionary. Okay. For this particular example, it's still true means apple is present, pen is present, apple is present. Okay. We need to return true if the word is present in the dictionary. Okay. Okay. So means we can dynamically split the string into from every position, and means not every position, the position which are making the word. We can't suppose split this string from here because L is not present in dictionary. We can split it from here because late is present in the dictionary, and we can further look for the uh, given given string, means if this is present or not. Means we can step by step verify whether the substring of a string are present in the dictionary or not. Okay. So we need to check in the dictionary. Okay. So these are the limits. Okay. All words are unique, and S and word dictionary consists of lowercase letters only. Okay. We have this string, so we what we can do is we can first check if L is present. So it's not present. If LE present, LEE is present in dictionary. No, it's not present. If LEET is present, so this is present. So we can we have confirmed that this particular part is present. We need to verify if the rest of the part is present or not. Then we start from this. If C is present, no, it's not present. If O is present, no, it's not present. If D is present, COD. If this wall is present, so this wall is present. So once we reach the end of this string, we can say we have found all the words in the dictionary. So I think that we need to return dictionary into a space separated sequence. Okay, so we just need to return if a given word can be break into the given dictionary's words. So this particular string, we will be not able to break it. Let's say we start from this cat. We have cat in the dictionary. Let's look for the SA and D sand. So sand is also present in the dictionary. But remaining string OG is not present. If we see this sequence, cats is present, okay, and is present, okay, then OG is not present. So we can't split this string into substrings which are present in the dictionary. So Okay, so first we can do is in order to check into the word dictionary into constant time, we can create a hash set of string. Okay, we need to store these words. So we can add these words to the uh, our set, and we can start from the zeroth index. So we can call a function and start from zeroth index, pass the string and the set. Okay, so this function is supposed to return the answer, which will be boolean. So let's define this function. So this is index, and this is the set of the words. Okay, so if we reach at the end of the this word, we can return true, means this particular string can be breaked into the words in the dictionary or set. Otherwise we can start from this position until we reach the end of the word, and we can take the substring, means the substring will be, let's say we have this current word, current possible word. So this will be s dot substring. So we are starting from idx value and ending at this index. We are adding 1 plus. So okay, and if this word, means if this current word is present in our set, contains current word, then we can move ahead in the then we can move ahead in the string. So means we have found a particular word, now we will look for the next word. Okay, this means the word from starting from index and ending at this value I is present. So what we can do is we can look for the further word, means we can call this function find take word starting from the I value, I plus 1 value, because till I we have found the substring, means this is from idx to I, this substring. So we have found this. Now we will start from I plus 1. We will pass this substring and the set. So if this particular word is will be present, if it returns as true, that means we have found the word. So we will not further call our function, means we can from here itself return the true that we have found the word, means this particular function have found the all the words. So we can directly return true from here. Okay, otherwise we can return false, means we have from idx to end of the word, we have transversed whole string and none of the substring is present in the current dictionary. So at the end of this we can return false. Okay, what issue we are having? Okay, this should be a string. Okay, so we the solution is working, but we need to memorize it. Okay, how we can memorize it? Suppose we have means we what we can do is we can store till this idx index, means after suppose searching this word and we are at this position, so for this position we can check in our dp if this starting from this particular position we can split the rest of the substring into the valid words. So that's how I think we can use dp. So we need to store two states, means true and false, at a particular index. So what we can do is we can initialize this dp and fill it with -1, pass the dp. Okay, okay. We have this dp. So in -1 represents we haven't calculated the answer. So if my value is not -1, means at this particular index, if it's not -1 means we have already solved this sub problem. Then we can return, suppose we store true for one value. So if dp of idx is 1, okay, so we can return true, otherwise we can return false. Okay, so we reach at this end value. So here it means our dp of idx will be 0 because we have reached the end and we haven't found the we haven't found the answer. So here our answer will be 0, and if it's true then this means dp of idx is 1. Okay, I think this should work. Mhm. We are getting a header. Okay, we haven't defined the n. And we also need to pass the dp in this function. So okay, so what the time that we are running it, let's submit this. Okay, so I think this is the solution for this. Okay, instead of using string we can also use string builder here. Let's solve this problem, then we can again look at this problem. Okay, hello Nihal ji, how are you? Hello Anup Kharsu, I think I know you, bro. From where are you, Anup? Nihal, my LinkedIn is on my channel also. I can paste that for you. Nihal, Nihal. जो बोले सो निहाल. Okay, we have this particular problem, partition equal subset sum. So the problem says given an integer array nums, return true if you can partition the array into two subsets such that the sum of the elements in the both the subset is equal or false. Otherwise, okay, subset. Okay, so we need. Okay, so the problem says if we can, we have some numbers and we need to put that numbers into two separate places, means in two separate bags, and the sum of the both numbers should be equal. If we can make that kind of partition, then we need to return true, otherwise false. So in particular this case, what we are doing, we are putting 155, that is 11, into one bag, and this 11 value into other bag. So that means both bags now have 11 value, so these are equal, so we can divide this particular array into two uh, sub arrays. And for this particular example, we can't divide. We can take any combination, but we can't make two bags with the equal values. Okay. So means we need to divide the total sum of the sub array into half into other bag and half into other bag. For example, here the total sum is 22. So what we are doing is we are putting 11 into one bag and 11 into one bag. So simply what we need to check here is, we need to check here is if sum of the elements in array has a sum equal to, if some elements has a sum equal to total sum in array divided by 2. So that's what we need to figure out only. If it's possible, then we can return true, otherwise we can return false. So let's calculate the total sum. So let's first define the size of the array, that will be num sort length. Now we need to find the total sum of the nums values. So sum will be, so I'm calculating total sum, so let's call it total sum. So for every element in nums, let's add that element into our total. So now we have a total sum, and what we need to find is, in this particular array we need to find the elements whose sum is equal to total sum by 2. If it is possible, if there are elements which fulfill this condition, then we can say that we can divide this uh, array into two subsets of the equal sum. Okay, so what we can do is we need to find if we can partition. So we need this array. We will start from starting of the array and try to pick a element if we, if that element is part of our sum is or sum or not. So initially we start from 0, then we can pass our nums array also, and with nums array we need to find the total sum by 2. Okay, so we need a private function, so it will return boolean. Basically we need to return boolean. We are returning this function, so we need a boolean return type, and we can find the partition, and we are starting from 0th index into our nums array, and we need to find this sum. Okay, so constraints are all the values will be positive in our sub array. So let's say if our so initially our sum has some value, and we will take some numbers and we will subtract the numbers from our sum. And when our sum reaches 0, for example, here the sum will be total sum by 2 means 11. So we will be picking up 1, subtracting from 11 gives 10, then we will picking up 5, it gives us 5, then 5 minus 5 0. So we can pick these elements and subtract from the sum. So whenever our sum reaches 0, we can say we have found a subset which has a sum equal to sum. Okay, and other than this, what we can do, we can, so we have an option. For example, here we are picking up numbers, but we have skipped this number, so we need to skip some numbers also. So we can either skip a number or can take a number. So let's first skip a number. So if we skip a number, so we will not include it into our sum, and we will just move to the next index, and we will there will be no change into our sum. Okay, and if we take a number, so that means, okay, it's a boolean type. Then we can take a number. So taking a number means we are considering the sum of the current number. So what we can do, we can partition. So we need to decrement that number from our sum, because we are now taking that number. So we are subtracting it from our sum. Okay. So we have chosen two ways. First way is we are skipping the current number, and other way is we are taking the current number. If one of the ways from this returns as the true value, means if it means it's possible to reach a sum of 0. So what we can do, we can return the or of these two values. Means either this will be true or this will be true, this will return true. Otherwise, if both are false, means none of the way is possible, so we can simply return false. One more thing, if our this index exceeds the length of our array, so we need to return false here. And also we need to cover an edge case. So that edge case, I think, will be, suppose we only have in our nums, if our nums looks like this, if it only has one value, so our total sum will be 1, and 1 by 2 will be 0, and means we will be returning true for that, but that's not possible. And also splitting an array of size 1 is not possible. So we can, okay, so I think this can cause issue in the case of odd numbers. Means the sum of the our array should also be uh, even. Means we can't divide odd numbers into two even numbers. Means if our total sum is odd, then we can return false, because if our numbers have a sum of odd, total sum as odd, then we can't just divide into two parts. So we can add this condition also. If our total sum is not equal to 0, then we can return false. And in the case of even, we can do by 2. Okay, I think this can work. Let's see. Okay, let's try also edge case like 1, and edge case like 4. Okay, means this is a single odd element, this is single even element. Okay, test cases are passing, because this sum will be odd, so we are returning false here from itself. And in the case of 4, we are passing 4 by 2, which is 2, so we can't take a number, means which has a sum of 2. Okay, so we need to memorize it, because this is a exponential solution, means having time complexity of 2 raised to the power n 2, because we are making two calls in n recursive depth, so that's why it's exponential. We need to memorize it. How we can memorize it? We have two variables are changing, one is index and other is sum, so we need a 2ddp. Okay, we need a 2ddp. Okay, okay, so we can define, so our sum will be a constraint. Okay, the total sum which is achievable, so like we have here. So I think this will be costly, like we have here nums I value, nums of I value is 100, means we can have a 100 value at max in on nums I position, and nums I length can be this, and we are dividing total sum by 2, so that means we need this size, or this size for our storing for our sum, and 100 for 200 for our index. So let's say if we have this dp, so n plus 1 will to store the this particular part, and to store the sum we can take this variable. Okay, and we can initialize the dp. Okay, it's 2d dp, so we need to initialize it like this. So this will initialize our dp to -1. Okay, now we need to pass this dp here. So this is our dp. Okay, so If we have already calculated answer for this sum and index, then means if it's not minus 1, then we can simply return this answer. Okay, otherwise we need to store this answer. Means what we can do is we can also, what we can avoid is when this particular calls return true, we are unnecessary calling, making call to this call. So let's say if my skip becomes true, then what I can do is for this idx and sum, I can mark it as true and return true. Means if this particular call give me true, then why should I go for this call? Okay, means instead of true we need to store is 1, so we are storing 1 for true. Okay, okay, so if it's 1 we can return true, otherwise we can return false. So this is our skip call and this is our take call. Okay, so if we reach here, this means skip is false. So what we can do is we can put into our this particular index and sum as the, if it's true then we can put 1, otherwise we can put 0, and at the end we can uh, return this take value. Okay, these cases are working. Let me see, check if sum can be greater than this value. 200 into, okay, it can't be greater than this value. Let's submit this. Okay, we are getting out of bound. Okay, we are checking that if our sum becomes 0, then we are returning true. Means what if we, okay, so in the case of this negative value, means if we have subtracted some greater value from our sum, that means if our sum reaches smaller than 0 value, then we can return false. So we are failing this test case. Let's see if this works. Okay, this test case is now passing. Let's try to submit this. Okay, so this was the solution. Bhaiya, I am currently in my second semester. Please tell me what I should do. Also, preparing the which branch. Okay, we need to also solve this problem. Where I can paste this code. I think preparing for gate is not worth it. Means if you really want to pursue means post graduation, then I think gate is good. Means I only in my college I only saw student from these branches from core branches giving gate. Means none of my friend in IT branch or CS branch has given the gate exam. You can give gate exam, but instead of preparing for that you can prepare for, I think, for DSA, or you can create a project. Okay, so you want to pursue from, if you want to pursue from IITs, or I think there are some more government colleges, I don't remember the name, which offer post graduation based on the gate score, so you can do that also. You have 3 full years, so I think you have a lot of time to get a place somewhere. If you were in third or fourth year, then if you were in fourth year, then it it was a concern. But you are in first year, so you can prepare for placement. So it's not that hard. Means you can prepare in 1 year, and you can get somewhere around 10 plus. So it's not that hard to get placement. Okay.
माइक बंद था।
ना,
ऐसे माइक में घड़ आवाज आ रही।
बेर ने कहीं कहीं था किर तो कहता होती वाइसता होती कि मैक पे हाथ लग गए थे
मैक पे हाथ लगे तो जल्दी होगी कहने होंगे। मैक पे हाथ लगे क्या जल्दी होगी।
तो यार भी तो डेली लग है पर आज जे क्यों आओ तो के भी डाकी सो ओके this is the value maximum mint 40 minus 3 9 starting from 4 max will be 4 into 5 5 max will be still 20 actually minus will be half min value max value now we reach the situation current value to minus 5 like if we take 4 into 5 which will be 20 max is 20 then we take minus 3 negative minus 3 means minus 320 into minus 360 and 20 still remains 20 we can maintain a current minimum. Okay, so we will open anything. Conjugate situation value is negative. So if our so y is negative, if it's smaller than 0, then if it's greater than or equal to 0, if it's greater than 0, smaller than 0, then we can take the maximum value as the max we have now, and minimum into this value is nums of 5. Means this is the current minimum till now we have. We can update minimum as minimum and यार ये कैसे होगा? अगर नेगेटिव वैल्यू है करंट मेरी, तो मैं मान रहा हूँ कि मेरे को मैक्सिमम वैल्यू भी मिल सकती है। ठीक है, मतलब कि अगर ये सीन है, या तो ये सीन है या फिर ये सीन है -340। सो ये दो सीन हैं बेसिकली। सो ऊपर वाले में यहाँ तक मल्टीप्लाई करके 20 हो जाएगा, इसको और मल्टीप्लाई करेंगे तो ये नेगेटिव वैल्यू है, तो मेरा नेगेटिव बढ़ जाएगा, मतलब कि मेरा नेगेटिव बढ़ जाएगा। मैंने क्या हो जाएगा नेगेटिव इधर। अगर सारे पॉजिटिव चलते जा रहे हैं अभी तक, मतलब कि अगर पॉजिटिव वैल्यू है तो मैप डॉट मैक्स ऑफ मैक्स मिनिमम कोई है नहीं अभी इधर। लेट्स से मैं 500 लेता हूँ मैप डॉट मैक्स ऑफ, मतलब लास्ट में मेरे को मैक्सिमम ही देखना है। मैक्सिमम क्या इस केस में 4 और 5 हो गए, यानी कि यहाँ 20 हो गया। 20 तो मैक्सिमम मेरा हुआ 20। फिर मैं -3 पे स्ट्राइक किया, -3 पे स्ट्राइक किया तो मैं मिनिमम और नम साई का ट्राई करूँगा पहले, वो ग्रेटर है क्या। अगर वो ग्रेटर नहीं है सो टू कंडीशन हो सकती है मेरी, इफ इट्स ग्रेटर और इफ इट्स नॉट ग्रेटर। मतलब एक कि ये कि मैं पहली बार नेगेटिव वैल्यू इनकाउंटर कर रहा हूँ, दूसरा केस कि मैं दूसरी बार नेगेटिव वैल्यू इनकाउंटर कर रहा हूँ। तो जब मैं पहली बार इनकाउंटर करूँगा तो मेरा नेगेटिव नंबर इंक्रीज होगा, यानी मेरा नेगेटिव नंबर जो होगा वो मैक्स इंटू मिन हो जाएगा। सपोज मैं यहाँ आता हूँ तो मेरा मैक्सिमम स्टिल रहेगा 20। ओके 20, जबकि मेरा मिनिमम माइनस जो कुछ है माइनस वैल्यू वो नेगेटिव ही रहेगी। फर्स्ट नेगेटिव है, ये 20 रहेगा तो ये 20 इंटू नम्स ऑफ आई मेरा मिनिमम हो जाएगा, ये वाला वैल्यू। देन मैं अगर इधर आता हूँ तो ये पॉजिटिव वैल्यू है मेरा, लेकिन मैं अगर एक नेगेटिव वैल्यू पे स्ट्राइक किया हूँ तो मेरे को मैक्स वैल्यू चेंज करना पड़ जाएगा। टू द नेगेटिव वैल्यू, मतलब इसको नेगेटिव वैल्यू में कन्वर्ट करना पड़ेगा मेरे को मैक्सिमम को यहाँ पे। हम्म, तो नेगेटिव वैल्यू यहाँ पे कैसे कन्वर्ट कर सकते हैं इसको, इसको इसका तो मैक्सिमम रहेगा ये। मतलब मिनिमम इंटू greater than max, then let's say we assign this value to max. Otherwise, कि यानी कि नेगेटिव के केस में इसको पॉजिटिव कर दिया, अगर ये बड़ा है तो, अदरवाइज इसको अगर ये मल्टीप्लिकेशन छोटा है मतलब कि मैक्स से बड़ा नहीं है तो मैक्स को मैक्स को ये डाल दिया, मतलब कि मैक्स ये है तो मिन भी यही होना चाहिए, मतलब कि मिनिमम ऑफ मिन। ओके, तो मिनिमम को क्या करना है, इसमें यार इशू रहेगा ये वाला आपकी बार देखना पड़ेगा इसका। इसको इसके लिए डिवाइड हम कर सकते हैं। चार पाँच 20 हो गया, ये छोटा है तो x हो गया ये, भी यही। चालीस पे जाएंगे तो ये तो सॉर्टेड है, 4 और 5 इधर आ गए, ये तो छोटा है तो मैक्स भी यही है, अब हमारा मिन भी यही है। अगर दोबारा इसमें आते हैं तो जो -3 है वो मल्टीप्लाई होगा इस वैल्यू से जो कि ग्रेटर देन मैक्स है, तो मैक्स हो जाएगा ये। Okay, this will be the max. Okay. Okay, -2, 0 पे गए, 0 पे गए तो मैक्सिमम लेगा आंसर हाई।